Hello student, again this is Professor Amoeba from Department of Computer Science, CMCS, Yotmal. Now we'll discuss the next point in unit number 5 of subject Distributed Operating System. The title of unit number 5 is the case study of Amoeba, and the topic of our today's discussion is the process management in Amoeba. Okay, so the key points are the processes as well as the threads that can be handled with the proper management in the Amoeba. Okay, so let's start with the first point, that is the process management in Amoeba. Dear student, a process in Amoeba is basically an address space and a collection of threads that run on that particular process. Okay, then after, a process is an object in Amoeba. Whenever a process is created, the parent process is given a capability for the child process, just as with any other newly created object. Using this particular capability that has been created earlier, the child can be suspended, then after it will be restarted or signaled, or it can be destroyed as well. In Amoeba, it is quite possible to create a new process on specific processor with the intended memory image stating right at the beginning. Whenever a process just created like this, a process can continue executing in parallel with its child and thus can create an arbitrary number of additional childrens. Okay, now here the children can create their own children leading to the tree of the processes, or you can say the tree structure of the processes. Now, how each of these processes can be handled in the format of tree, and that's why our next point of discussion is the process handling levels. A process management in Amoeba is handled at three different levels. Okay, first one, at the lowest level are the process servers, which are kernel threads that are running on every machine. Here, whenever you are interested in creating a process on a given machine, another process will perform an RPC with that machine's process server, providing it with the necessary information in order to just create a particular process. Then the second level is, at this next level up, we are having a set of library procedures that provide a more convenient interfaces for the user's program. Within this, several flavors are provided. They do their job by calling the low-level interface procedures. And finally, the third level is the simplest way to create the process is to use or to run a server which does most of the work by determining when to run that system process. Okay, so these are the three different levels how the process are handled in Amoeba. Now, the next point is the process descriptor. Now, as far as this process descriptor is concerned, it provides the information about the process to be get executed. In this process descriptor, one field tells which CPU architecture the process can run on or will be executed on. Another field contains the process owner's capability. When the process terminates or it is stunned, the RPC will be done using the capability to report that particular event. It is also just contain the descriptor for all the process segments, which electively define its address space as well as the descriptor for all its respective threads. And finally, the process descriptor also contains a descriptor for each thread in the process. Dear students, the content of a thread descriptor is architecture dependent, but as a bare minimum, it contains the threads program counter and the stack pointer. So these are some of the contents as far as the process descriptor is concerned. Again, it may also contain the additional information necessary to run the thread, including the other registers, the thread, and the various flags that are used in the thread. Again, the brand new process contains only one thread in their process descriptor, but the stunned process may have created additional thread before being stunned. So this is the diagrammatic representation of the process descriptor. Okay. Now the interprocess or the process interface procedure. There are various interfaces which can be used in the process interface procedures. First one is EXEC, that is executable. It has two input parameters. First one, the capability for a process server, and the second, a process descriptor. Its function is to run an RPC with the specified process server asking it to run the process. If the call is successful, a capability for a new process is written to the caller for use in controlling the process in the future references. Then after the second thing, that is the gate load, it returns the information about the CPU speed, then after the current load and the amount of memory free at that particular point or at that particular moment. It is also used by the run server to determine the best place to execute a new process. Then after there is stun. It is a process parent can suspend it by stunning it. More commonly, the parent can give a process capability to a debugger which can stun it and later restart it for interactive debugging process or purpose. Then after, the next thing is the normal stun. With a normal stun, the process sends a message to the server. It is currently waiting for saying in effect, I have been stunned, finish your work instantly and send me a reply. If the server is also blocked, waiting for the another server, the message is propagated further all the way down the line to the end. Okay, means until and unless the reply is generated, the message will be transformed to the or propagated to the next server. Then after there is the emergency stun. The server at the end of the line is expected to reply immediately with the specific error message. In this way, all the pending RPCs are terminated almost immediately in the clean way with all of the servers finishing their work properly. Here, the nesting structure is not violated and no long jumps are needed. Again, an emergency stun will stop the process instantly and does not send any message to the servers that are currently working for the stunned processes. The computation being done by the server will become now orphans, and when the servers finally finish and sends the replies, these replies are ultimately discarded. Okay, so these are the key points as far as the emergency stun is concerned. So students, then after we are having the thread. Now the Amoeba supports a simple thread model. When a process starts up, it has one particular thread. During its execution, the process can create the additional thread and existing thread can be terminated. When a new thread is created, the parameter to the call will specify the procedure to run and the size of the initial stack. Although all the threads in the process share the same program text and the global data, each thread has its own stack pointer, and its own copy of the machine register. In addition, if a thread wants to create and use the variables that are globally to all its procedures but invisible to other threads, library procedures are provided for that purpose, and such variables are called as the global variables. Okay. One library processor here will allocate a block of the global memory of whatever size is requested and will return a pointer to that. Blocks of global memory are referred to by the integers, and a system call is available for a thread to acquire its global pointer. Here, three methods are provided for the threads to synchronize. First one is the signals, second one is the mutexes, and the last one is the semaphores. As far as the first one, that is the signal, is concerned, it can be rest, caught, or ignored. Asynchronous interrupts between the processes use the stun mechanisms. Then after, the second thing, that is the mutex. A mutex is like a binary semaphore. It can be in one of two states, either locked or unlocked. Now, trying to lock an unlocked mutex causes it to become locked, and the calling thread will be executed or it will continue. Trying to lock a mutex that is already locked causes the calling thread to block until another thread unlocks the mutex. If more than one thread is waiting on a mutex, when the mutex is unlocked, exactly one thread will be released. In addition to this, to the calls to lock and unlock the mutexes, there is also one that tries to lock the mutex, but if it is unable to do so within a specified interval of time, there will be timeout and the error message will be written or the error code will be generated. Okay. And finally, we are having the semaphores. It will just slower than that of the mutexes. In addition to the respective additional call, is provided to allow a down operation to time out, and if it is unable to succeed within a specified interval. So dear students, these are some of the points as far as the amoeba is concerned. Okay, thank you.